Question number 9 says that a field is in the shape of a trapezium whose parallel sides are 25 meters and 10 meters. The non-parallel sides are 14 meters and 13 meters. We have to find the area of the field. So let's draw the field which is in the shape of a trapezium and let it be ABCD with side lengths as given in the question. To find the area of this trapezium, let's divide it into two shapes by drawing a line segment BE which is parallel to AD. So the length of BE will be equal to 13 meters as lengths or the sides opposite to each other in a parallelogram are equal in length. Now as we know that the total length for DC is 25 meters and the length of DE equals 10 meters as it's opposite to the line segment or the side AB, we get the length of EC to be equal to 15 meters. Now as we see that we have found out all the side lengths for the triangle BEC, we start finding its area by making use of the Hurons formula as the height for this triangle is not given. So the area A equals under root S times S minus A times S minus B times S minus C, where S is the semi-perimeter for triangle BEC while ABC are its three side lengths. So we will have to find the semi-perimeter for triangle BEC, which can be found by adding up the three side lengths and dividing it by 2. So let's start adding. We add 13 plus 14 plus 15 and let's divide that by 2. So on calculation we get the semi-perimeter S to be equal to 21 meters. Now that we have found out the value of the semi-perimeter, let's start finding the area for triangle BEC by substituting these values back into the Hurons formula. So we get under root 21 times 21 minus 13 times 21 minus 14 times 21 minus 15 meter square. This on further calculation gives us under root 21 times 8 times 7 times 6 meter square. That one for the calculation we get it as under root 7056 meter square, which gives us the area of triangle BEC to be equal to 84 meter square. Now that we have found out the area of triangle BEC, we can find its height h, which is perpendicular to the base EC. Now this height h is also the height for the parallelogram ABED, so we will be able to find the area of parallelogram ABED as well. So let's start finding the height. The area of triangle BEC can be found out by making use of the formula half into base into height, where EC can be the base and h can be the respective height. So let's start substituting. The area as we know is already 84 as we had calculated by Hurons formula equals 1 by 2 times base length is 15 times h. So we can write that as h equals 84 times 2 divided by 15. So let's keep it as it is. Now our next step is to find the area of the parallelogram ABED. So the formula to find it is base into height. So we can substitute the value for base as 10 meters and the value for the height as 84 times 2 divided by 15. So this on calculation gives us the area of parallelogram ABED to be equal to 112 meter square. Now as we have found out the areas of the two shapes for the given trapezium, which is a parallelogram and a triangle, we can write the area of trapezium ABCD equals the area of triangle BEC plus the area of parallelogram ABED. Let's start substituting the values. We add 84 plus 112. So we get the area of the trapezium field ABCD to be equal to 196 meters square. And this is how we find the total area for the field ABCD, which is in the shape of a trapezium.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.